May I invite the next group to join the stage with such an engaging topic about androgen receptor promotes hepatocarcinogenesis by regulating the expression of IMRC7, IGFBP3, and NTSR1. Presented by Ms. Yitao Yang.
Hello everyone. It is my great honor to attend this year's IMRC. I am Yang Yitao from Naval Medical University of China. Now I want to share with you that androgen receptor promotes hepatocarcinogenesis by regulating the expression of IMRC7, IGFBP3, and NTSR1. I will elaborate from the following four aspects. HCC is one of the major world public health issues, and according to epidemiological surveys, HCC is one of the most common malignant tumors and the fourth leading cause of cancer deaths worldwide. It was among the top 3 causes of cancer deaths in 46 countries and was among the top 5 causes of cancer deaths in 90 countries worldwide. Also, epidemiological evidences have shown that HCC presents significant gender differences. The incidence of male is 2 to 7 times higher than that of female, and the 5-year survival rate is higher in women than in men. So we guess that androgen receptor and androgen may play important roles in HCC. This study aims to investigate the effect of AR on HCC and the underlying mechanism. Methods are as follows. Currently, our study is still in vitro experimental level and are basically the phenotype study and the functional study. Our experiment is roughly divided into 3 steps. First is a phenotype study. The second is to identify the key molecules that may be regulated by AR. The third one is to provide firm evidences to support the functions of our target genes and the regulatory effect of AR on the target genes. Then we conduct luciferase assay and chip assay to further determine the regulatory effect of AR on our target genes. We use DHT to stimulate AR to detect the effect of DHT. After that, we knock down our expressions of our target genes and analyze it on cell phenotype, which is 2 cell lines. One is SK-HEP1 cell line, which has higher background level of AR, and we use it to conduct AR knockdown cells. The other is HEPG2 cell line, which has lower background level of AR, and we use it to conduct AR overexpression cells. Then we use these 2 cell models to conduct cell phenotype analysis. The key molecules were identified with transcriptome sequencing. We have 3 criteria. First, they should be significant differentially expressed molecules. Second, they must have been reported to be associated with carcinogenesis. Third, they must have significant effect on survival with public data analysis. This is how it is this experiment. Next, let's take a look at the results. Our phenotype study have shown that AR had a positive regulatory effect on cell migration and invasion, as shown in Figure 1 and Figure 2. AR has a negative regulatory effect on cell apoptosis, as shown in Figure 3. We conducted transcriptome sequencing with AR overexpressed genes, and we firstly identified the differentially expressed genes. During the genes, we further narrowed down our targets with GO and KEGG analysis, which has enriched the pathways related to cell migration, cell invasion, and apoptosis. We also conducted survival analysis with public data. 4 genes were selected out after this analysis. To further explore the underlying mechanism, firstly, by luciferase assay, we found that AR could significantly increase the promoter activity of BIRC7, IGF-BP3, and anti-SL1, but the promoter activity of NDUFA4L2 was not significantly increased, indicating that AR could positively regulate the expression of BIRC7, IGF-BP3, and anti-SL1, but could not directly regulate the expression of NDUFA4L2. Then, SHIP assay showed that AR could directly bind to the promoter region of our target genes. Furthermore, when stimulated by DHT, we found that the promoter activity of our target genes was significantly increased, indicating that DHT can activate AR transcription and can further upregulate the promoter activity of our 3 target genes. On the other hand, we observed the influence of our target genes on cell phenotypes after knocking down the expression of target genes with siRNA. And the results show that AR can affect cell migration ability by regulating the expression of anti-SL1, but BIRC7, IGF-BP3 cannot affect cell migration ability. AR can affect cell invasion ability by regulating the expression of anti-SL1 and IGF-BP3, but BIRC7 expression did not. AR can affect cell apoptosis by regulating the expression of all our 3 target genes. So we come to the conclusion that AR can promote HCC development by transcriptionally upregulate the expression of BIRC7, IGF-BP3, and anti-SL1, which can be enhanced by DHT. The above is why to share with you today. Obviously, it is still a primary evidence. We're still conducting in vivo experimental level, but the evidence is not presented here. We're still struggling to conduct furthermore experiments to ensure the rigor of our study. Thank you for your attention.
Thank you for valuable information.
Any comments from our judges?
Thank you very much for your presentation. Could you share to us what is the functions of your 3 target genes?
Our 3 target genes can affect the phenotype of our cells, include cell migration, cell invasion, and apoptosis, but they're not the same at all. Actually, the result
in cancer cell. So these 3 genes, what is normal function of them?
We roughly studied it cell carcinogenic cells. Yes. Can enhance the HCC cells.
Do you have the information of the expression of these 3 genes in other cell or in normal cell?
In normal cell, maybe. Sorry, I didn't study it.
All right, because so from your work, so it seemed like that these 3 genes could be a good target for drug discovery. And I asked the question because at the end, so the aim of the next study may be to inhibit these 3 genes, and if it plays some important functions, so maybe it will be affect your study further. That is the aim of my question.
Oh, okay. Thank you.
Let's have some questions from our judges from online.
Okay. Thank you for your presentation. And I have quite a question that how you select these three genes from the group of the genes that you got from your study. Because I see that you can you hear me?
Sorry, pardon me, can you say it again?
Hello, can you hear me? Yeah.
Yes.
My question is that what's the criteria that you select these three genes from a group of the genes that you got from your study?
Okay, we have three criteria. First, they must be significantly expressed differentially in molecules. Second, they should be previously reported to be associated with our carcinogenesis. Third, they must have significant effects on survival with public data analysis.
Okay, thank you.
Okay, thank you.
Okay, thank you so much.